Hello and welcome back to ABC Foundation's Carbon Farming Outreach Program webinar series. This is the fourth part in this series, and today we're going to be looking at blue carbon. A quick disclaimer that the information contained in this presentation is the property of ABC Foundation and may only be used for internal purposes. The content within this presentation is deemed accurate for the purpose of promoting carbon farming and land management practices. Discussions of the ACCU scheme and financial benefits of carbon farming are general in nature, and attendees should seek independent advice for their specific circumstances. Access and use of any of the information contained in this presentation may only occur by the written consent of ABC Foundation's CEO. I also just want to acknowledge the Whadjuk Noongar people, whose country I am on today. And ABC Foundation acknowledges and pays respect to the past, present and future elders and traditional owners of this country and throughout Australia, and recognises their continuing connection to land, waters and community. We celebrate the continuation of cultural, spiritual and educational practices of Aboriginal and Torres Strait Islander peoples. So what are our learning objectives for this webinar? Well, firstly, we're going to understand what blue carbon is and which coastal and marine ecosystems store blue carbon. Then we're going to recognise blue carbon ecosystems as living, connected systems that support sea country. Number 3, understand how carbon is captured, stored and protected in coastal environments. Number 4, identify why blue carbon ecosystems are important for climate resilience, biodiversity and communities. Number 5, recognise how land management decisions and disturbance affect blue carbon health over time. And number 6, gain confidence in engaging in informed decisions about blue carbon opportunities, risks and responsibilities. So firstly, what is blue carbon? Well, blue carbon is defined as all the carbon stored in coastal and marine ecosystems. The key difference here is the type of ecosystems where the carbon is stored. Here they are water-based ecosystems rather than land-based ecosystems. And these ecosystems function slightly differently and have different management techniques, hence their own grouping. So blue carbon ecosystems still function by taking in and storing carbon, but they do this slightly differently. So blue carbon ecosystems exist in anaerobic sediments, which just means there's very low or little oxygen in the soil. And so this allows carbon breakdown and storage that lasts much longer than land-based ecosystems. And because there is little to no oxygen, it is much harder for that organic matter to break down into CO2, as the decomposers that break down that carbon also need oxygen to survive. So what kinds of ecosystems actually store blue carbon? Well, there's 3 main types of blue carbon ecosystems. There are mangroves, which you can see in the top picture, salt marshes, which are seen in the middle picture, and seagrass meadows. And other than those 3, there are some other less recognised ecosystems, which include coral reefs, kelp forests, and phytoplankton, plus many more, but these are less recognised at the moment. Just like land-based ecosystems, blue carbon ecosystems are living, dynamic, and interconnected. They rely on interactions with other systems, and damage to one can have ripple effects into the other systems. So protection and repair can deliver multiple benefits at once: climate mitigation, biodiversity improvement, and coastal protection, etc. Before protection and repair can even start, it's important to know that blue carbon ecosystems can vary widely across regions, and management activities that work for one group or area might not be appropriate for your goals. Tropical regions are typically dominated by mangroves. These are areas along the equator and northern Australia, and you can see in the picture on the right there, that's the orange dots everywhere. Whereas temperate regions have much more salt marshes. So for example here, that's southern Australia and Europe, and they are displayed as the yellow line on the graph. But it's important to know there's no one size fits all, and management techniques should be tailored to your specific circumstances. So how do blue carbon systems actually work? Blue carbon ecosystems share the same first step as land-based ecosystems: sunlight and carbon capture, and then sugar formation. Plants in these ecosystems capture CO2, sometimes from the air, but also from water, for example, seagrasses. And this is what makes blue carbon ecosystems unique. Capturing CO2 out of the water is much harder than air, and this is because of the slower movement of particles inside water. Underwater plants have another challenge to overcome: sunlight capture while underwater. This is because light is blocked by the water as it passes through, getting dimmer and dimmer the deeper you go. Past 200 meters, plants cannot grow as there's not enough light, and past 1000 meters, light is completely blocked. And what this means for blue carbon ecosystems is that plants actually cannot grow in most of the ocean, which is about 92.7%. Well, once CO2 and light is captured, it is converted into sugars, which is the exact same as land plants. And these sugars form the structures of the plant, such as roots, shoots, flowers, and etc. Where some of it is dropped on the surface and buried, which is then broken down and turned into soil carbon. And plant roots also exude compounds that are rich in carbon, which just adds to the soil carbon. Once buried in the soil, carbon-rich material then breaks down into soil carbon compounds. But this process is much slower than on land due to the lack of oxygen. Whereas on land, organic material is broken down into CO2 more readily. In blue carbon ecosystems, this carbon is kept as stable forms more readily, meaning that they won't break down as often. This means that blue carbon ecosystems can have a much greater carbon storage per unit of area compared to land-based carbon. And so in blue carbon ecosystems, thick layers of carbon-rich sediment can build up over time, and this can be up to meters deep. And that's also seen on the picture on the right there. And this also means that there could be a greater risk of reversal with blue carbon. So if soils are drained or ecosystems are degraded and cleared, all that carbon that's stored in the soil can be released back into the atmosphere as CO2. Besides carbon capture and storage, blue carbon ecosystems also provide many important processes. Plants in blue carbon ecosystems trap sediment, they settle particles that are suspended in the water, and they stabilize the seabed. This reduces the effects of erosion and storm effects. They also help regulate water flow. They help with nutrient cycling and transformation, which leads to improved water quality, filtration, and prevents algal blooms. And they also provide habitat for many species. Okay, so what are the key blue carbon ecosystems that you might encounter? Mangroves are salt-tolerant trees or shrubs that grow in intertidal waters, and they have specialized tangled root systems. Intertidal waters just means it's an area that is sometimes dry and sometimes wet with the changing tides. So mangroves have specialized adaptations for low oxygen soils, and keeping salt out or excreting that salt out, and also staying upright in a shifting substrate. And the term mangrove can be talking about a species of tree or shrub, but it can also refer to the ecosystem or habitat. Mangroves are also important for coastline protection. They're an important fish and nursery habitat, and they provide water filtration and nutrient cycling. The next one is salt marshes, which salt marshes are coastal wetlands that are flooded and drained with salt water from changing tides. They often have deep mud and peat soils, and what that means is they are highly rich in carbon compounds. They usually have a wide variety of species with various adaptations for survival. It's not like mangroves where they're all very similar. Typically, the vegetation is very low down to the ground and is interspersed with bare patches or salt pans where the salt dries out of the water. And they are also an important habitat for invertebrates that are then a food source for birds and fish. And salt marshes, they also help to stabilize sediments, protect coastlines, and etc. The last major type is seagrass meadows or seagrass beds. And so seagrass meadows are flowering plants that have evolved to live completely submerged underwater in the shallows of the ocean, so within that 200 meters. And so seagrasses have specialized adaptations for gas exchange, because underwater you have to get all your gases out of the water. They have adaptations for staying submerged, they're called rhizomes. It's a type of root that keeps them stuck to the seabed. They have flexible leaves, as they have to move a lot with the tides. And they have very efficient light capture, as they are getting less light than land-based plants would. And they also have to have adaptations for underwater pollination, which is quite interesting. And seagrass meadows are also an important feeding and breeding habitat for many different marine species. But why is blue carbon important to us? Well, the ocean, and therefore blue carbon or blue carbon ecosystems, is one of the most important systems in regulating Earth's climate. The ocean absorbs about 30% of all human carbon dioxide emissions. It also buffers changes in temperature, meaning that temperature swings will be less extreme with heat waves. And many climate and weather patterns are driven by the ocean. Where if you wanted some more information about that, please see webinar 3 about climate change. And so mangroves, salt marshes, and seagrass meadows, they can act as a barrier to protect coastlines. These ecosystems, they all reduce the effects of storm surges and extreme weather. They trap and stabilize the sediment, which reduces the effects of erosion. And they also reduce the energy of incoming waves, which lowers the effects of, again, storms and erosion. Blue carbon systems do more than just regulate Earth's climate and protect coastlines. They also provide for many different sea creatures. So as we spoke about, they're a breeding ground. Many species specifically return to different blue carbon ecosystems to safely breed. A lot of them are also a nursery habitat where many fish or crustacean species spend the beginning stages of their lives here. And they're also a food source. The plant material is a food source for many species, and then those species are in turn a food source for other species. So blue carbon management and disturbance, how does that affect our outcomes? Disturbances like clearing, dredging, and coastal development can have disastrous consequences on blue carbon ecosystems, as disrupting these sediments can release thousands of years of stored carbon, and once damaged, recovering these systems can be very slow. And damage to one system can cause knock-on effects in others. So if you removed seagrass meadows from a coastline, the storm effects might be more intense, which then might create erosion on the shoreline, and that might then degrade salt marshes, and so on and so on. But other disturbances could include clearing and coastal development, which results in fully cleared patches of land, and they can no longer perform any of their functions, they're fully degraded. Restricted or altered tidal flows is another one. So this can prevent nutrients, water, and dissolved gases from reaching the plants, which in turn will lead them to die, and then will cause a decline in vegetation. Invasive species can also outcompete native species, which will then lead to a loss of biodiversity and vegetation. Pollution and or nutrient runoff from agriculture can lead to eutrophication, which eutrophication is algal blooms. And so algal blooms, there's algae submerged all throughout the water. They then take all the dissolved nutrients, oxygen, carbon dioxide out of the water, and it physically chokes out the other plants and they die. Boating and recreation can also damage plants and harm the animals if it's done irresponsibly. And disease and pests can spread quickly, damaging or killing plants and causing a decline in vegetation and biodiversity. Some of the key risks specifically to mangroves, they include coastal development. So mangroves are being cleared, the water flows are being altered, and the sediment is being changed. This is partly for aquaculture, where land is cleared for aquaculture farming, and this also then leads to nutrient runoff and eutrophication as those effects cascade down. There's also palm or rice oil farming, where land is cleared and the wetlands are drained. This leads to the carbon being re-released back into the atmosphere and the soil being completely changed. This is most prevalent in Southeast Asia, however. So there's same key risks for salt marshes. Sea level rise is one of them. As the ocean level is rising due to climate change, salt marshes, they sit in a very delicate position where they sit on usually quite flat land that isn't very high above sea level. So a small rise could fully submerge a salt marsh. Coastal development is another one. Clearing of the vegetation, altered water flows, and changes in sediment again. And this has previously been done as people described salt marshes as unproductive, but they are actually highly biodiverse. Altered water flows is another one. The salt marshes need to be periodically flooded, which brings them water and nutrients, etc. Without this periodic flooding, they will die. So those key risks for seagrass meadows, coastal development and dredging is a big one for it. This just leads to the removal and or burial of seagrass beds and increases the amount of sediment in the water column, which then in turn reduces the light availability to these plants. Physical damage, again from boating, anchoring, etc. This damages the seagrass and recovering them can be quite slow. Poor water quality is another one where sediment blocks the light. Contaminants can also harm plants, and nutrients can cause algal blooms, which then block light and take nutrients and gases out of the water. And just some statistics about those blue carbon ecosystems that we just spoke about. So an estimated 340,000 to 980,000 hectares of blue carbon ecosystems are destroyed each year. And so since measurement, up to 67% of total mangroves have been lost. At least 35% of tidal marshes have been lost. At least 29% of seagrass meadows have been lost. And that's the source for that information on the screen there. So what indicators can you look out for to see how healthy a blue carbon ecosystem might be? Well, the condition or health of a blue carbon ecosystem determines how effectively they can deliver critical services like carbon storage, coastline protection, and habitat provision. And learning to identify and then appropriately respond to these different indicators is essential for blue carbon management success. And especially tracking these changes over time can show how effective that land management has been. So blue carbon ecosystems can only effectively capture and store carbon when they're healthy. Some of the signs of healthy ecosystems include dense and structured vegetation. This just means vegetation that has many layers made up of many different species, and it is quite dense and compact. It'll also show strong growth rates and no signs of disease. Another one is a high carbon storage. You'll see in the sediment, it shows that it's quite dark and has high levels of carbon. Other signs of healthy ecosystems could include the presence of animals. So healthy and functional ecosystems show a diversity of fauna, including the key species for that environment. Water quality is another one, where a healthy ecosystem will show balanced nutrients, sufficient oxygen levels for their plants, and clear water. Sediment stability as well, so healthy roots trap and bind sediment. In healthy ecosystems, you'll see minimal erosion and stable or increasing sand levels. Hydrology and tidal flow is another indicator. So in healthy ecosystems, the natural tide is not blocked, the salinity will be balanced, and the ecosystem will show a high connectivity with the other surrounding ecosystems. Having low pollution and disturbance is another one, so low contaminant levels, minimal human disturbance, and the absence of invasive species. Also, the ecosystem's resilience could be another indicator, where the ability to resist and or recover from extreme weather and climate change, where healthy ecosystems will have a high resilience. So what principles can we use when protecting and restoring blue carbon ecosystems to make sure we're effective? Well, the most important one is obviously protecting what's already existing there. So protecting existing intact ecosystems is a priority, as protection requires less input and takes less time than full-scale restoration of an ecosystem. This also avoids releasing the stored carbon back into the atmosphere. And protection might involve controlling invasive species and or pests, reducing pollution in the area, maintaining natural water flows, and managing human activities, etc. The next one is to work with natural processes and not against them. So restoring the natural processes like water flows, sediment movement, and salinity will then help the ecosystem to start recover by itself. And letting ecosystems regenerate naturally where possible is ideal, as this lets the plants only grow where they really should be growing, and this lowers your input costs. Naturally regenerated systems are also usually better adapted to the local stresses. Next principle is to use native species and local biodiversity. This is because native species are already adapted to the local conditions, which allows them to establish and survive more easily. Ecosystems with a high local biodiversity tend to have stronger ecosystem function, stronger food webs, and higher carbon sequestration. And it also avoids issues with non-native species that could become invasive and then reduce the local biodiversity. Choosing the right site location and restoration method is also very important. So here you want to ensure that the restoration or protection work that you are intending to undertake is appropriate for the local conditions of the area. And you want to connect with experts as their input will be valuable. And poor planning and site selection is one of the leading causes of project failure. Look at some formal blue carbon farming methods and nature repair activities. Methods for blue carbon farming are currently quite limited, with the only one being the tidal restoration of blue carbon ecosystems method. Projects using this method can earn ACCUs by reintroducing tidal flow to wetlands, and this is also a form of carbon sequestration. And projects using this type of method will have requirements that they must uphold. Farming methods have specific requirements and obligations you must uphold as the operator. One of those is upfront documentation. So prior to starting a project, the operator must prepare a hydrological assessment, a project map, an environmental risk plan, and project management and maintenance plan. There are also permanence obligations, just like other carbon farming methods, and this is just a requirement to keep the carbon locked away for a set period of time, usually 25 or 100 years. Some of the other requirements and obligations that you might see: monitoring and reporting. So ongoing monitoring and record keeping are required, and you need to submit regular reports using this. Projects also must undergo at least 3 independent audits over their lifetime. And there's also some restrictions on the land use. So while a project is active, certain activities will be prohibited on that land. So that could include things like farming and harvesting plants or animals, applying fertilizer, and etc. But stacking a blue carbon farming project with a nature repair project might be an option for those wanting to deliver multiple benefits. Stacked projects must follow approved methods for both blue carbon farming and nature repair activities, and those can be seen on the Clean Energy Regulator website. And projects can then deliver carbon and biodiversity outcomes at the same time. And again, some of those requirements are on the DECU website or the Clean Energy Regulator website. Highlight the importance of learning from sea country, and that's through observation and monitoring. So traditional knowledge has been built through long-term observation, and integration of this knowledge could be quite beneficial. Ongoing and regular monitoring and observation is essential for project success, where changes in species, water, and vegetation all signal ecosystem health and can then inform your decision making. And continued learning also strengthens adaptive management. Important aspects of these kinds of projects is trust and consent. And this is because decision makers like Aboriginal elders and boards shape how country is managed. And free, prior and informed consent, also known as FPIC, is essential for projects to succeed. Where FPIC is just the right of Indigenous peoples to make voluntary, well-informed decisions about the activities that affect their lands, waters, resources, and rights. And this is also because carbon farming projects can affect future land use options. So a lot of these projects have permanence obligations, which we spoke about, and they also restrict certain activities, like the removal of plant material, where each method or type of activity will have their own types of restrictions. But because of this can restrict self-determination and cultural practices, and possibly reduce future economic opportunities and even more. And also a lot of these responsibilities extend into the future generations, where they will have to manage them. Formal project, what are some of the next steps and everyday actions people can undertake? Well, firstly, if you want to actually begin a blue carbon project or look into it, the first step is always to fully understand the processes behind blue carbon farming. Then from there, you can utilize freely available tools and resources to assess your viability of the many options you have. After that, you want to connect with experts and collect baseline data and then set your goals for the project. And also lastly, make sure that you check legal and regulatory requirements. But making a difference in the blue carbon space doesn't require you to start a full-scale formal project. Some of the everyday actions that you can do include reducing your own carbon footprint, so walk, cycle, or take public transport where possible, or reduce your reliance on fossil fuels. And this helps to slow climate change, which is already threatening blue carbon ecosystems. And another important one is to mind what goes down the drain. So avoid putting chemicals, oils, and medications down the drain, and try to use eco-friendly products where possible. Some other actions include reducing plastic use, so cut out single plastics like bags, bottles, and food containers. And this is because these harm wildlife and takes hundreds to thousands of years for them to fully decompose. Practicing responsible recreation is also quite important, so avoid disturbing blue carbon ecosystems when boating, fishing, or walking. Sustainable seafood is also quite important, so look for certifications that say that it's sustainable, and this helps prevent overfishing and damaging practices in the oceans. Supporting local conservation is also another one, so volunteer for coastal cleanups or restoration projects in your area. Advocating for coastal protection as well, so stay informed about what's going on in your area and push for change and protection of these ecosystems. Support different organisations and initiatives, so donate to or follow groups that currently work on coastal restoration and protection. Just a little quick slide about some of the useful resources and more information if you want it. So the first resource is CMAP. This is just a map that has many different map layers that show depth, habitat, different ecosystems, and many, many more data points. That's available through cmapaustralia.org/map. And if you wanted more information about some of the current blue carbon farming methods, that can be done on the Clean Energy Regulator's website, and that's on the screen now. There's also the Blue Carbon Conservation, Restoration and Accounting Program, which just has more information on some of the current funding and or grants that you might see, and that's available on the DECU website through the link on the screen. Also on the DECU website, there's the DECU Marine Publications. So this is all the different publications around many different areas of blue carbon and marine ecosystems, and that's also accessed through the DECU website through the link on the screen. Well, what's next for ABC Foundation? Our next online workshop is the 13th of May 2026 at 11 AM. This is the same as our last workshops. It just goes through some of the background knowledge, science, and systems behind carbon farming in Australia. You can check it out or look at some of our other events and webinars and sign up through the link on the screen. And any queries you have, send it through to that email. That's coming up is Traditional Ecological Knowledge, or TEC, and Fire Methods. This will be released on the 20th of May, and this webinar will go through the background knowledge, science, and systems behind TEC and fire management in Australia. Again, you can sign up through the link on the screen, and any queries, send it through to that email. Joining us for the fourth part in our Carbon Farming Outreach Program webinar series. We hope to see you in the next one.